Oh, thanks. That's weird. So as long as nothing, I don't know how long my phone will last, but I'll run and get a power cord if I need to. So you guys can still all see this? Thumbs up across the board. Okay, so I'm going to use my favorite group's data as an example. Dawson, you asked me to use this in lab.
Rough, professor.
Favorite's sarcastic. Dawson just specifically asked. Okay.
I called dibs.
You called dibs. Okay, so first thing everyone wants to do, everyone has one of these. So the Tuesday labs that had issues, I've corrected the data and posted it. There's a big old bold thing that says use the data below here. So just use that data. I've fixed things for this afternoon's labs, so everyone can just do this. They can just copy and paste their data. Right, and I know, is this big enough for you guys to see? I know, like, when I share screens, it's tiny. It's still very tiny. Is everyone...
That's good.
Okay. Oh, it probably has to do with my monitor. Okay, so after that, you don't need the raw data anymore. Goodbye. There. And then you can even call this raw data if you want. All right. So, how, I guess I could just do it right below, right? Okay. So the next thing you can do is copy the data that you need, right? So in this group's data, we have our blanks, standard 1, standard 2, standard 3, 4, 5, et cetera, right? So we don't care about anything down here. This is all, these numbers are all just, like I've said before, absorbance of the plastic. We're not interested in those. Okay, so we've copied it, set this up. Next, I don't want to type this, I guess. So the next thing you want to do is make your little table over here. You guys should all basically have these tables from the protocol, like you've already set them all up. You know what all your sample IDs are. So sample ID, standard 1, standard 2, standard 3. Let's see if Excel is going to smart. Yep, sweet, standard 5, right? So then I'm assuming control DF1, control DF and $20, right? Ooh, Dontrol, that's what I wanted. Control, right? So every sample that went into your, this is drug rep 1. Every sample that went into your plates, right? Drug rep 1, DF10. Rep 1, DF20. 2, I could just copy this and it'll be faster. Two. Okay. Any questions about that? That's pretty straightforward, right? Oops. Does anyone know what I'm missing?
It would just be the blank.
Yep. And that wasn't like a trick. I just forgot to type it in. Blank. Okay. So then we want a column for average absorbance. text. Sorry that. Average absorbance. I don't want to do this. I'm not going to put that in there. Nah, I will. I don't want to mess you guys up. Corrected absorbance, right? So in this column, absorbance. In this column, we're going to put our absorbances minus our blanks, right? So remember, the first step in analyzing our data is we want to subtract this signal out from our blanks. So, I mean, that's the first thing we want to do for analysis. The other first thing we want to do is make sure there's no outliers. So I'm making like a 5 or 10% difference from the average, basically, our call for outliers. So like looking quickly at this stuff, these guys don't have any real outliers. Yeah, so no real outliers. So we don't have to get rid of anything. So the first thing we have to do is average our signal from our blanks. Bam. Done. Any questions about that? Okay. This thing is recording, right? Isn't there?
Yes, it's recording.
Yeah, if you look in the top left corner, it has a recording thing and then like a red dot.
Yeah. Oh, well, I'm gonna, oh, I see it on my phone. I don't see it on my computer. Okay.
I think you're good.
All right, so this is our raw data, right? This is where we're gonna do some, basically this is our raw data. This is going to be our corrected data for blank. What? No, just, why? Stop helping me, whatever. I'm leaving that alone. Excel's trying to help me. Okay, so we want to subtract the absorbance in each of these cells, or vice versa. We want to subtract the absorbance from the average absorbance from our blanks from each of these cells, right? So we basically just go equals this minus that, right? So now this cell ID will equal A1 minus the average absorbance of our blanks. Does everyone see that so far? Okay. And then if we cheat and put these dollar signs up here, what I've told Excel now is that I want to take this, so this cell equals the cell that is whatever 9, 11 cells above it minus this cell only, right? So I've locked this cell ID, but this cell ID is going to follow wherever I move stuff. So equals.
How do you do that again?
Just put your dollar signs in front of your column ID. So Q's are column ID, and then a dollar sign in front of the row ID. So this will locks the column and the row. You can do it in other ways where you only lock the column or only lock the row. If you put it for both, like this cell ID that I just pointed to with my hand, this cell ID won't change. Got it?
Yeah,
Okay.
thank you.
So now if we grab the bottom right, scroll over, all these cells are now subtracting, right, their corresponding cell ID, or subtracting this from their corresponding cell ID. So if I double click here, now it's saying this cell minus the lock cell, right? This one, this cell minus the locked cell. And then, you know, like all the way over here, this cell minus the lock cell, right? Any questions about that?
Do you just do it for every row?
Yeah, well, yeah. So now that I have all these cells like this, I can highlight this entire row, grab the bottom right, drag it down, and now every single cell in my plate has subtracted out the average blank. That makes sense?
I just have a question. Did it based off of the numbers that had already been in the corrected data for blank section, or was it bringing numbers from the raw data selection?
This set right here.
Yeah, the one that you just did.
Yep. So this entire plate is now like this cell equals the original cell in our plate minus the blank.
Oh, okay. So it's the raw data information minus.
Yep. The raw data minus the average absorbance values. Yep.
Okay. Thank you.
Yep. So now this is why I said last week, if you just spend the time to do this last week, you could just copy and paste this data in. So like if you had already done this, it would be done. But if you didn't, you get to have the fun of going average this, right? So that's where we put, this is our corrected blank data. So average that. I'm going to cheat a little bit, which isn't going to, like, this isn't going to fix my problems. This is going to make more problems for me, but it's faster than typing average over and over and over again. So now, basically Excel like connects everything in a linear fashion. So whereas before I did this equals thing and linked those cell IDs and I dragged it over and down, it mapped back to each of these cells. What I did over here was, again, equal, average, these three cells, right? Does everyone still see that? Who can guess what this cell is going to equal? This one right below the original.
Is it also going to be 0?
Nope. So like what cell IDs is this going to be linked to?
B? Like group B, like the one below it?
Yeah, exactly. So like Excel's trying to help, but you know, it's trying to help in the way that Excel tries to help. So because I copy and pasted that formula down, it took this information linked to here and just moved down one cell, right? And then this guy is, come on, this guy is down 2 cells. This guy is down 4 cells, etc. Like Excel will link and move things like that. So like I said, that technically makes more problems, but it's faster than typing average. So,
So
yep.
How did you do that again? Because we have the same numbers as you, but we're not getting 0 for the blank and those other values for the other group.
So we're averaging the value of these 3 cells.
Yeah. Yep.
Do these 3 cells equal 0.18, 0.14? I mean, negative 0.1 and.
Yeah, I think our problem is just it's rounding differently on my Excel. So it's just a very, very, very small number instead of 0. That's what we just realized.
Yep.
Okay.
So if you can right click, where are you? Format cells, put number or general. It should do that. And then you can also move the decimal place with this. So like, I don't know, you can keep going if you wanted to. Yeah, so there you go.
Okay.
We don't care about anything in the, whatever that was, the trillionths place.
Decimal place.
Okay, so now we have to fix what I've done, right? So you can just grab these 3 boxes, move them to the next triplicate, right? So standard 1 went to A4 through 6, right? A4, 5, 6. This is where our next standard is, right? Boop. There's the average corrected absorbance of standard 1. Standard 2, same thing. Just grab your boxes, bring them over to where standard 2 is. Click. Standard 3. Click. Standard 4. Click. Standard 5. Standard 5. Click. Right? Now we have average absorbances of all of our standards. Any questions about that? Okay, so while I'm here doing this, I'm just gonna fix these as well. See, like, so you see these cells just keep going down because the cells are going down. So then this is our control DF1, control DF10, come on, control DF20. This one, right? 10, yep, 1, 10, 20, yep. And this one, so like I said, if you had done this before, this would all this auto programming would be done for you and you wouldn't have to redo it. Where am I? Right here? Yeah. DF10, DF20. Okay, everyone good so far? Okay. So I suppose what I forgot to put in here. Nah, screw it. I'll just put it over here. All right, concentration of protein. Okay, everyone's still good? Right, so we're just going to leave the blank as blank because it's not going to be included in our standard curve. We know the concentration of standard 1 mgs per mil. We know the concentration of standard 1 was 0.125. Next was 0.25. The next was 0.5, 1.0, 2.0. Make sense? So now we basically made our XY values for our standard curve. So if we come over here, we go to insert. Yep, we want a scatter graph. So it's going to, depending on your machine and your version of Excel, it's going to be in different places, but you can go to insert up here, chart, scatter, XY scatter. It doesn't matter. I mean, I think you can even right click, right? Insert, maybe not, maybe not. Insert tab or insert thing up here. So XY scatter, we don't want lines or anything like that. We just want scatter. So now we have a blank graph. And I'm gonna make this bigger. So if we click the graph, go up here. So usually same thing, it's somewhere up at the top, or you can right click, select data. I don't usually bother with chart data range. The first thing I do is add a series into the legend here. Something's in my driveway, my phone is telling me. So add a series, it'll push the plus sign, add a series, name it. I'm saying this is absorbance versus protein concentration. Okay, and I don't know what the heck it did, but we're gonna go back, click it again, select data, go here. So now we should have two little options here. It says X values versus Y values. Click on the bar over here for X. We want the concentration of protein to be our X values, right? So we're going to highlight those 5. Hit return. Now we go to Y. We want the corresponding absorbance. Make sure my phone's not dying. We want the corresponding absorbance values to equate to those concentration values. So select those 5. Hit return. And I'll do labeling later. So then you just hit OK, and ta-da, there's our scatter plot. I've seen better and I've seen worse. Dawson's engrossed. He's not gonna respond.
I'm so sorry. Thank you so much.
Not supposed to thank me for that. Okay, so here is our standard curve, right? The next thing we want to do, like this is basically useless. So we're going to go to add chart element on my machine in my version of Excel. It's in the top left. We're going to insert axis titles. I'm going to start with primary horizontal, which is our x-axis. And this is protein concentration mgs per mil. Okay. What the heck? Oh, stop. You're done. Let me unselect. Thank you. We're going to go back to add chart element, axis titles, primary vertical. And we want our y-axis or our vertical axis to be absorbance. You can put absorbance at 562 nanometers. You can put OD, which is optical density, at 562 nanometers. Doesn't matter. Okay. Is everyone with me so far? Is that not going to move? Any questions? Okay. So now we're clicking on our data set range again. We're going to go back to add chart element. And now we want to add a trend line. So trend line, linear forecast. I don't know. No, don't do linear forecast. I don't know what that's about. Do linear. So click linear. Ta-da! Now we have Excel's basically given us a linear formula that has a remotely okay fit to our data. This over here. Everyone still with me? Okay. What else am I missing? We need to do standard deviation. Okay, I guess I'm gonna, yep. STDV equals STDV. Okay, sorry. So similar to how you can type in and make Excel do averages for you, you can also make it do standard deviation. So if you just do equals STDEV, that'll give you a standard deviation formula.
P or S?
I don't even use PRS. I mean, these data is so small, it doesn't matter.
Okay.
You can literally just type STDEV and select it. And so similar to how we did the average, you're literally just going to select the 3 data points that correspond to that, but I got to actually drag that over. So this is not, there we go. That's standard 1, right? And we only, well, I'm only going to do the standards because I'm going to show you how to put it into the graph. I think you're supposed to do it for all your data points for your table here, but I'm not going to do that. So same way we did average, we're just double clicking and fixing the box locations so that they go to where they're supposed to go. Standard 4 and standard 5. Okay, everyone with me still?
Yeah. So why did we not do the rest of them, like the controls and the drug rep 1 and 2?
I think you guys are supposed to for the table, but like I just showed you how to do it. Just keep doing it.
Okay.
Sense. Okay, so I did it for this because now we are going to click on, if you click on a dot, it'll select all dots. Double click. And let's hope this lets me do it. No, so scratch that, try clicking the data range, go to add chart element. I gotta fish around for this because it's like add data labels. No. I can never like remember exactly where this goes. I don't want trend line. Scanner combo. If anyone knows how to do this, feel free to. No. I'm trying to add error bars. And there's a place to do it. Yep, okay. Chart. Go back to add chart element. Right there, error bars. Let's see if this is going to work. Oh, okay, yeah. No. Sorry, I'm trying to, you can normally click on those things. Like you're supposed to be able to click on these data points, and it's supposed to be right here. If anyone can beat me to this. Label, trend line, services? No. So that's the battery left. Did someone just do something? Oh boy, add Y error bars. Nope. Okay, I don't know. We're gonna go back to insert chart element, go to error bars. Oh, now I got 20% battery. And we're gonna start with standard error, right? So we don't want X error bars. So click on the X error bars. Can we delete them? We can delete them. Just click delete and they go away. Sound good so far? Everyone who's still here? Okay, so now click on your Y error bars and that should pull up an option somewhere. You might have to double click it. Go to custom. Custom, specify value. And then like you'll have this bar pop up where you can select the data you want, right? So we want our positive error bar to be this, except I probably clicked on, let's try the range. And then we want our negative to be that also. Okay, there, okay. Look, it worked. So now our error bars are fit to our standard deviation values. Any questions about that? Cool. Okay, so now we can click on our linear curve here that we built a few minutes ago. We want to display equation on chart and display R squared value on chart. I want you. Everyone good with that? Okay. Now we have our y equals mx plus b formula. I'm just going to type them right here. So mx, oh, we don't even need that b, right? So m is 0.1756, b is 0.0389. Okay, so we have our y equals mx plus b formula. Does anyone remember what we're supposed to rearrange this to apply it in this situation? Nobody knows?
Professor.
Yep.
Don't you make it x equals? Do you set it to x?
Yeah, exactly. Yep. Concentration. Okay, so we have, it's not how you spell concentration, is it? Okay, so we can now, in the column concentration of protein, we can type in equals our formula, right? So if we rearrange this to equal for x, it's just y. So our y value is our absorbance, right? It's literally the absorbance value from our machine. So we do parentheses y, click on the box, minus b, which is the value right here. I'm going to lock that cell. Y minus b divided by m. And I'm going to also lock m in place. Okay. So then, because I locked those cells in place and I told it to use basically the cell just to the left of it, copy and drag. Right. So now we have the concentration of our samples in mgs per mil for everything. Okay, so does anyone remember what the criteria for picking the concentration, picking the absorbance value at which you use to calculate the concentration of your protein from? What the criteria for that is? Anybody know?
Wait, can you just restate the question?
So how do we know which absorbance value we can trust to plug into our y equals mx plus b formula?
Would that have to do with approaching catalytic perfection?
Nope. It's more mathematical than that.
So like it wouldn't have anything to do with like kcat or km?
Nope. It's an outcome of the linear standard curve we built.
Is this the thing where there's like a range of numbers that it has to be between like the two? I think it was like 2 to 5 or something like that. I don't know the exact numbers, but
Yeah, so we have to pick an absorbance value that falls between our least concentrated standard and our most concentrated standard, right? So our least is 0.125 and our most is 2. But like I said, you have to pick it based on the absorbance values that correspond to those. So like the bottom of our curve is way over here, and then the top of our curve is over here. So our least concentrated standard corresponds to an absorbance value of 0.031, and our most concentrated standard corresponds to an absorbance value of 0.394. So we can only use absorbance values that fall between 0.031 and 0.394 when we use our y equals mx plus b formula. Does that make sense? How can I do this? I don't want to do it. I don't want to do it because I don't want to confuse you guys on what to add to this curve. So this curve is done. Like this is what your graph should look like. It should just be your data. So basically now we would have to look at the absorbance values of our unknowns, right? So this is kind of annoying. All right, so I mean, can anyone tell me what the issue is here with this data set? So does this absorbance value fall within the curve or outside of the curve?
Outside of the curve.
Correct. It's more than 3.94, right? It's 0.425. So technically, we're not supposed to use this one. Does this one fall in or outside the curve?
Barely inside.
Yeah. All right. So what I'm going to do, if you guys need feedback on this, just get my feedback on this. I'm going to remove the lowest value from this curve, which is going to change this information. So this changes a little bit. 6.2, but hopefully this fixes things.
Should we do that as well?
It didn't really fix anything. You guys need a steeper slope, really. This one. Oh, for me? Thanks. I might need a phone charger. Thanks. I don't want to confuse you guys. So if you get really poopy numbers, basically you'll just have to meet with me on an individual basis. So correct, we shouldn't use this because it's outside of our curve. This one's barely inside our curve, but I don't believe it. I think we're like losing specificity down here at the bottom of your standard curve, Dawson. And then this one's also outside of it, right? This is way below it. So we can't use this or this. Thank you. I won't need it, but who knows? What's up?
Leave them in, or do we remove them? That is a question.
I just keep them in for now.
Okay.
You come see me. Okay, now my phone's plugged in. Okay, so for this one, I mean, you're going to have to pick 0.425. I know it's technically outside of the curve, so it's not I mean, in the real world, you would just redo this. Like, that's how this would work in the real world, is you'd redo your curve and retest your samples. But I don't think anyone wants to do that. Okay, so Dawson, for your group, use this guy, 0.425. So the concentration of the protein concentration of your control is 2.19. Wrong way. Or 2.20. Okay.
Okay.
So then for your drug rep 1, we're in a similar situation where this guy's basically just outside of your curve, but this guy's out of your curve and this guy's barely in your curve. And those numbers are negative, right? So use him as well. So the protein concentration of drug rep 1 is 2.19. Basically, they're identical. That makes sense? And basically, I mean, anyone that's watching, if you have numbers that are like basically identical to this, just do the same thing. Like I said, in the real world, you would redo this. Okay, but our last one, slightly more ideal, right? So this guy's outside of the curve. This guy's basically within the curve, but he's negative, so we're not going to use him. And this guy falls like happily in the middle. So his protein concentration is 1.45 or 1 point, should be 1.42 for some reason, but okay. Does that make sense for everything so far? Now, so for a hypothetical, let's call this unknown Z. Sure, unknown Z, DF1, unknown, I didn't spell unknown right. And unknown Z, DF20. Okay, because I'm obviously not looking at everyone's data, so I don't know what it is. Let's pretend this guy has an absorbance of 0.601. This guy has an absorbance of 0.095 or 95. And then this guy 0.099. Jesus, 0.99. Right, so this is basically for anyone, you guys can still see me, right? This is basically for anyone whose DF of 1 is way outside of the curve, way too concentrated. It has dilution factor samples that are within the curve. So you'd still just drag down, apply your concentrations, right? Everyone still with me? So what's the one next step that we have to do to make these values usable? I'm gonna make this guy red because he's way outside the curve, right? So what do we have to do to samples that have been diluted to fix?
Could you apply the diluted one, diluted factor?
Yep. This one's not supposed to be there. Let's pretend that's a 1. Now he's outside of the curve. Yeah, so you have to correct it by applying the dilution factor you used, right? So this guy we're gonna mark red because we're not using him. So now we literally just do equals the calculated concentration of protein times our dilution factor, 10. So the undiluted concentration of this sample is 51.88 mg per mil protein. Mg per mil. Does that make sense? And that's basically all there is to it, sort of. What's the last thing on the table? You guys got to put the coefficient of variance. Yep, so you got to add the coefficient of variance, which is just standard deviation divided by average times 100. So you can just do equals standard deviation divided by, that's over here, I think, though, isn't it? It's not the protein concentration. Yeah. So it's the standard deviation of your absorbances divided by the average of your absorbances times 100. And then same thing, like once you plug in all your numbers, you can just drag it down. I think that's the last thing for this activity, basically. Any questions?
For the BCA analysis assignment, are you just looking for us to submit the table in our graph?
If you want, you can include the table. You really just need to submit your, no, I lied. Yeah, submit your table, graph, and in your table, you should have your corrected protein concentrations, and that'll take care of it.
Okay, so kind of like add another column onto it for that then?
For the corrected protein concentrations?
Yeah,
Well, I mean, yeah, when you build your table, yeah.
okay.
Because this one's just going to equal this. Our dilution factor is 1, so it's times 1. It just equals this, again, times 1. Right? And I'm just, I'm highlighting these so you guys can see them better, I hope. So that is the accepted protein concentration of your unknowns. And then I think it's, I don't suppose anyone's looked ahead and they know what quantity of protein we need for next week. I think it's 1 microgram. Nope, 30 micrograms. Okay. So basically showing you how this is going to work for next week. Quantity, volume needed for 30 micrograms protein. Okay, so this is basically almost identical to what we did with the RNA. It's just different numbers. So we want to know the volume of this sample we need to basically transfer 30 micrograms of protein, as opposed to before where it was like 1 microgram of RNA. So I know that 1 mg per mil is the same as 1 microgram per microliter. So how does this work? Pen. We want 30 micrograms. Okay, X microliters times protein. Oh God, X microliters times Y micrograms per microliter equals 30 micrograms of protein. Yeah, okay, so it's basically just 30 divided by concentration, right? So this is 30 micrograms, which is how much we want, divided by our concentration of our protein. Does that make sense to everybody? If so 30 micrograms of protein divided by X micrograms protein per microliter solution equals our Y microliters of solution. What is this? Anyway, so, right, so 30 micrograms of protein. Hold on, I'll put parentheses. So 30 micrograms of protein, which is how many that's the quantity of protein we want, divided by the concentration of protein in our sample, right? So, you know, whatever our value is here. In this case, it's 30 micrograms of protein. Can you guys see my face while I'm talking and my screen is shared? Okay. So 30 micrograms of protein divided by the concentration of our sample in micrograms per microliter. That's basically micrograms per microliter is the same as milligrams per milliliter, will equal Y microliters of solution. Okay, all of our units cancel. Ooh, thanks. Seltzer water. Promise it's seltzer water. So it's just 30 micrograms. I'm back to the computer now. Divided by the concentration of our samples. Enter. Microliters. Ugh. Microliters. Okay. So, next week when we do this, Dawson, your group needs 13.8 microliters of this sample to transfer 30 micrograms of protein. Does that make sense? And then because the formula transfers, you can literally just copy and paste it. And then you see this. So comparing your two samples here, Dawson. Oop, I need control too. Forgot to highlight control. Okay, so you can see here that the concentrations of these two samples is basically the same, right? Your control is 2.1, 2.2 rounding. 2.2 rounding or whatever. Yep, 2.2 rounding. The concentration of your drug rep 1 is 2.18 when we round. So they're basically the same volume, right? So 13.6 microliters of this guy, 13.8 microliters of this guy is the volume you need to transfer to move 30 micrograms of protein. And they're basically the same because they're basically the same concentration. Whereas,
So
go ahead.
for the DF10, would we multiply the value by 10?
Yeah, exactly. Yeah. Which is what we did down here in this example, right? Unknown Z, DF10. The absorbance falls. Oh, God, it doesn't. Why didn't anyone stop me? Fuck. Okay, so I had to backtrack and look at this. So no one stopped me. 0.9 doesn't fall within our absorbance range, right? But the imaginary number of 0.195 does. So if you had a DF10 of 0.195 falls in your curve, you apply our y equals mx, please, ymx plus b formula to that. You get your concentration, but you have to correct it by 10. So your uncorrected concentration of protein times your dilution factor will give you the corrected protein concentration. Does that make sense so far still? Okay, so going back to this, right? So these guys have basically the same concentration of protein. So basically the same volume needs to be moved to move 30 micrograms of protein. This guy's, roughly half as concentrated, right? So he's 1.4 instead of 2.2-ish. So you need to move more volume to move the same quantity of protein, right? It's less concentrated, so you need to take more of it to move that quantity of protein. And then this example way down here, he's got a concentration of 8.9, so you need even less. So the more concentrated something is, the less volume you need to move to take the same quantity of whatever's dissolved in that sample. Any questions? Does anyone want to share their screen and ask questions? Because that's basically the gist of it. I suppose that's it then. I mean, if no one's got questions, That's the end of the tutorial, if you want to call it a tutorial.
I have one question. I'm in like the Tuesday lab. Did you know what was wrong with like the BCA, like the blanks?
Yeah, I think we have too much sucrose in our lysis buffer. So you can add, oops, someone sent something in the chat. So you can add sucrose to lysis buffer to basically place osmotic stress, osmotic stress on the cells. So you have a high concentration of solute outside the cell. So water is going to flow out of the cell. Does that make sense?
So you added it into a hypertonic solution or a hypotonic solution?
Hypertonic. Yep. So that's supposed to help, it's basically supposed to help explode the cells, because our goal for this whole practice or this whole activity is to get the proteins out of our cells so that we can analyze them. Does that part make sense? So
Yes,
you can add
yes, yes.
sucrose to, yep, you can add sucrose to lysis buffers to help do that. But if the concentration of sucrose is too high, the sucrose will reduce our copper and give us that false positive I was talking about. So the problem in the Tuesdays lab was I didn't use the NPB lysis buffer to make the standards. So basically there was unaccounted for background noise in between our samples and our standards. Does that part make sense?
So if you didn't, so you'd use the NPB lysis for the blanks and our like unknown proteins. So then what was used for the standards?
It was like, they're the same standards we used last week. I think I used PBS. So there was no sucrose in those to like give that extra signal. So the Wednesday lab, I remade the standards to include those things. So Wednesday can just do it as is. The Tuesday labs, I uploaded fixed data by subtracting the noise from introduced by the sucrose.
So basically like the standards were used like as using like PBS as a diluent, and then these had like the lysis stuff. Or
yeah,
okay.
And the contents of the lysis stuff gave us a false positive. So that's why you're supposed to make your standards also with the same solution you make your lysis buffer and stuff up with. We did this in the spring, and it didn't happen. So it wasn't supposed to happen. And 2 out of the 4 groups Tuesday morning didn't have it happen at all. So I don't know. I fixed the data though. So you guys can also analyze it as is with the fixed data. It's just, that's biochemistry in action basically. And like I said, in the real world, you would just redo this.
All right, thank you.
Yep. Yes. Let me do this. How can I do this? Yes. And Sarah left. Okay. That's that. I mean, if no one else has any questions, you guys can head out.
Thank you. Good night.
Yep. Have a good one. Can't wait to
Thank you,
wake up.
Professor.
Yep. Can't wait to wake up at 5:30 and drive back to work.
Wait, so I have one more question. When you were making the like fixed data for like anyone who had lab on Tuesday, did you use like a formula to like to change the values?
Yeah, sort of. I mean, I basically fudged things a little bit. I basically subtracted. I took one of the Excel sheets and I subtracted the background data from where the plastic absorbance or the blank should be. So I took the difference. So the two plates that didn't have any issues in the morning had normal blanks. Normal blanks come at like 0.07 or something. So I subtracted 0.2. I did 2.46 minus 0.7. Got that number. So equals 0.246 minus 0.07. Right. And then subtracted this artificial value from all the wells that had it, basically, to theoretically remove the background noise. I have to, where the hell is the stop recording thing?
It should be on like the bottom.